Djokovic served an example of a velocity, speed in a given direction. The velocity of the ball is changing because the ball is accelerating due to gravity. The speed is a measure of how fast something is moving. Speed is defined as the distance covered per unit time. If we know two parts of this equation, we can find the third. The path of the table tennis ball being hit follows a parabolic path. The ball is a projectile, and the factors changing its path and speed are gravity and air resistance. The horizontal and vertical components of projectiles are independent of each other. Upwardly launched projectiles, such as the table tennis ball, slow down until they reach their maximum height. Then they begin to descend and accelerate until it reaches the ground. The object will have the same speed coming down as it had at the same height when going up. The ball machine shooting balls is an example of inertia because it demonstrates the ball staying in motion in a somewhat straight line. However, gravity and air resistance are acting on it to alter the ball's speed and direction. Inertia is Newton's first law. It says that every object continues in a state of rest or of motion in a straight line at constant speed unless it is compelled to change that state by forces exerted upon it. Ball hitting the backboard demonstrates Newton's third law, action and reaction. This law says that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Therefore, when the ball hits the board is also hitting the ball. The reason we don't see the backboard move like the ball does is because of the blackboard's much greater mass. They both have the same force, but one has a greater mass, so it has less acceleration. Elastic collisions. Collisions of objects such as a racket hitting a ball show the conservation of momentum. Me hitting the tennis ball is an elastic collision because the objects collide without being permanently deformed or generating heat. There is a conservation of momentum in this collision. The momentum of the racket is transferred into the ball. You don't need to swing the racket very hard because momentum equals mass times velocity. The bigger mass of the racket means the ball will travel faster. Torque is applied to the tennis ball when he hits it at an angle. Torque is different than force because torque produces rotation. A torque is produced when a force is applied with leverage. The lever arm in this situation is the racket. The player's arm provides the force. The formula for torque is torque equals force perpendicular to the lever arm times the lever arm. The picture of the man serving represents universal gravitation. Newton's law of universal gravitation states that every object attracts every other object with a force that for any two objects is directly proportional to the mass of each object. This law is expressed as force is proportional to the mass 1 times mass 2 divided by the distance between them squared. The universal gravitational constant, G, is 6.67 times 10 to the negative 11. When this is put into the equation, we find that force equals G times mass 1 times mass 2 divided by the distance between them squared. We can use this equation to discover the force between any two objects if we know their masses and the distance between them.